everybody, this is our lecture on ossification. And ossification is how you take a tissue of some kind and convert it from whatever that tissue type is into bone. And we're going to see that happening during fetal development and a little bit after fetal development as well, using two main forms of ossification. One is intramembranous ossification, which involves converting dermal tissue into bone, and the second one is endochondral ossification, which involves taking hyaline cartilage and converting that into bone. So let's start with intramembranous ossification. Because it's taking dermal tissue and converting it to bone, we can call this, we can call the bones that are made this way, dermal bones. But we can also have these, this type of ossification happen because of injury to a bone. So, or not to a bone, to the tissue, to the dermal tissue. So some sort of blow, like a accident, could result in a little bit of intramembranous ossification happening where it's really not supposed to be. And when something is where it's not supposed to be, we call that ectopic. So we would call that an ectopic bone. An example of that would be a bone spur. So if you've ever had kind of a sports injury where you, land funny on something or take a blow with something to a body part and you end up with this like kind of funny lump of bone in a place where it's really not supposed to be, that's a bone spur. It's an ectopic bone. Now, generally speaking, the dermal bones, when they're forming during fetal development, these are the bones of the skull, and your clavicle, which is what I've drawn here as a clavicle. So those are examples of dermal bones. So what happens is we're going to have to first remember the word mesenchyme. Remember, those are the stem cells, or the mesenchyme is the collection of stem cell tissue that you'll find in connective tissue. So when we talk about stem cells for bone, we mean osteoprogenitors. And remember from last lecture, I mentioned that I would be using those words kind of interchangeably, osteoprogenitors versus mesenchymal cells or mesenchyme. Now also remember that once we have osteoprogenitors, what they're going to do is turn into osteoblasts, and the osteoblasts build bone. And by the time they're done building the bone matrix and then calcifying it so that it's nice and dense, then they differentiate into mature bone cells, which are called osteocytes. So remember that every time you see osteoprogenitors moving in someplace or becoming active, that means that they're going to be turning into osteoblasts, they're going to be building bone and turning into osteocytes. So you're doing that whole construction of bone process here every time you see these osteoprogenitors or the mesenchymal cells, however you want to call them. So what's going to happen here? We've got this, piece of dermis that we're trying to turn into a clavicle as a fetus. And so on the outside, we're going to have these mesenchymal cells just kind of cluster around the outer edge. And they're going to start forming the periosteum. And remember, in the periosteum, we have osteoprogenitors, which we know because we're talking about mesenchyme. So we know that we have to be talking about osteoprogenitors. Those osteoprogenitors are going to be turning into osteoblasts, which are going to turn into osteocytes. So they're forming bone, specifically a layer of compact bone called the bone collar that's going to form just underneath that periosteum, so just deep to it. So this compact bone, as we know, is going to eventually cover the entire outer shell of the bone, but not the inside, which is going to be made up of a lot of spongy bone. So this compact bone layer, this bone collar, is just going to spread along the outside, just right underneath the periosteum in all directions, not just this kind of 2D direction, but all around, until it completely covers the bone, just like you would see when you look at a normal bone once it's fully formed. Now, meanwhile, we need to start thinking about making what's in the medullary cavity or the marrow cavity with the spongy bone deep inside. So here we have, again, our mesenchymal cells, our mesenchyme, our osteoprogenitors, and they're clustering here in the center, and they're making what's called an ossification center. So they're going to be turning into osteoblasts, which turn into osteocytes, and they're going to keep on growing and differentiating and spreading out until they fill the entire marrow cavity with spongy bone. So there, now we have a clavicle. Now, when you think about the bones of the skull, think about a little newborn baby. They have that kind of soft spot on the top of their head. So like if you look at the top of a baby's head, so here's the baby's like eyelashes looking out. This is a messed up looking baby. But there's this little spot here at the top of the baby's head that's a soft spot. They have another one here, there's one on the other side, and then there's one in the back, littler soft spots. So these are called fontanelles. And this is why, soft spots. This is why you don't want to sit there and push on a baby's head, because it is a soft spot. It is a place where the intramembranous ossification hasn't completed yet. You're still kind of in the, ossification center stage of it. You don't have the bone collar fully formed all the way. And as the baby grows, for a couple of months, it's going to take for that to grow in and completely ossify. So that's why babies have those soft spots. They're just not done doing their intramembranous ossification yet. Okay, now endochondral ossification, on the other hand, this is where we're taking hyaline cartilage and we're going to convert it into bone. So let's cross that out. So just steps without a number on it. With endochondral, and the word tells you that endochondral, endo means inside, chondro makes you think of cartilage, so we're turning cartilage from the inside into bone. So here is, I'm going to just use the femur as an example because it's an easy bone to draw. Here's a piece of hyaline cartilage in a fetus, kind of roughly shaped like a femur, and it's going to grow the way the cartilage grows, which we know that both bone and cartilage grow interstitially, which means growth from the inside, and it also grows appositionally, which means surface growth, so growth on the outside. So the hyaline cartilage is going to be growing just like all of the fetus is growing, and while that's happening, a couple of different things are going to happen. So when we just look at this piece of hyaline cartilage, we know that any sort of cartilage is covered with a protective membrane called the perichondrium. So let's write that down. So the perichondrium would be the protective membrane around cartilage, and the cells of the perichondrium are called the perichondral cells. So what's going to happen here is something called angiogenesis. Genesis means new, or beginning of. Angio refers to blood vessels. So this is just blood vessel growth. Or you can think of it as growth of new blood vessels. And these new blood vessels are going to be growing into the perichondrium. And anytime we see angiogenesis during this whole process, it's going to be the trigger to cause something to turn into something else. It's going to be a stimulus that converts something or causes a reaction. So when we have angiogenesis into the perichondrium, that's going to cause those perichondral cells to differentiate into periosteal cells. And we know from our previous lecture that the periosteum is the protective membrane around bone, and we know that it consists of cells, in particular osteoprogenitors. Sorry, there goes my doorbell, which is a ridiculous doorbell. Sorry about that. It's going to go off for a second on me. Okay, sorry about that. So the osteoprogenitors are going to turn into osteoblasts, like we've said before, and they will turn into osteocytes. So every time you see that happening, we're going to have that process going on. So what are these osteoprogenitors turning into osteoblasts, turning into osteocytes? What are they creating? They're creating a bone collar right under the now forming periosteum. So here the pink is the perichondrium. It's turning into the periosteum. This angiogenesis comes in, turns those perichondral cells into periosteal cells instead, which are osteoprogenitors, which turn into osteoblasts, which start building the bone, and we start making the bone collar. And the bone collar, just like we saw before, is just going to grow all the way around, making compact bone all the way around this developing bone here. Now, in the meantime, we've got the inside to deal with, and we have a bunch of chondrocytes, or hyaline cartilage cells, living in here, and they are going to be doing a couple of things. They are, one, becoming hypertrophic. That means they're growing too big. They're experiencing an overgrowth. So anytime you see hypertrophy, you're growing too much. And then they're secreting two things. Alkaline phosphates. Alkaline phosphates are going to help to make the matrix of this cartilage really, really hard and dense. And if you think back to our previous lecture about tissues back in Unit 2, we know that cartilage doesn't really have a good blood supply. It's difficult for chondrocytes to get nutrients in the first place. So if you make that matrix harder, it's going to become really difficult for those chondrocytes to get their nutrients. So this is going to cause apoptosis of the chondrocytes. So they're essentially killing themselves with these alkaline phosphates. Now, another thing they're secreting before, they completely go through apoptosis is something called vascular endothelial cell growth factor. So let's take that word apart really quick. Cell growth factor, that's easy to figure out what that means. You're making some kind of cell grow. It's a chemical, which is what a factor is, that makes cells grow. And what kind of cells? Vascular endothelial cells. So that might not be so self-explanatory, but vascular, that means arteries and veins and blood vessels, things like that. So the endothelial cells are the cells that line arteries and veins, and they are going to cause angiogenesis. So vascular endothelial cell growth factor triggers angiogenesis, and this is going to form periosteal buds. These are just a name for the clump of blood vessels that we're going to see in the next step, which is going to be on the next page, where we have all these blood vessels that are, a result of the angiogenesis caused by the vascular endothelial cell growth factor that was released by these dying hypertrophic chondrocytes. So what happens with these periosteal buds? They're going to be growing into the diaphysis of the bone, and then they're going to grow into the epiphyses, which we'll see in a second. But they're going to be carrying a couple things. They're acting like a little highway for other kinds of cells. One, osteoprogenitors, which we know are going to turn into osteoblasts and osteocytes once they get to their final destination. And what their final destination is something called a primary ossification center. Then, when they go, we also can form a secondary. I left that one off. So secondary ossification center too. Oops, secondary. So they're forming ossification centers, just like we saw with intramembranous ossification. We've got osteoprogenitors kind of clustering together in the middle of the bone, starting to make osteoblasts, which are starting to make bone, which are starting to turn into osteocytes. Another type of cell that's using the periosteal buds to go deep into the marrow cavity would be your hematopoietic cells. We already know that those are the cells that are stem cells for blood. We know that they exist in the marrow cavity, so that's how they got there. They use those periosteal buds. Okay, so far we've turned our perichondrium into the periosteum. We started forming a bone collar, which is the layer of compact bone that's going to eventually go all around. Our chondrocytes became hypertrophic. They were secreting alkaline phosphates to make the matrix super dense so that they're starting to go through apoptosis, and they're releasing this vascular endothelial cell growth factor that triggers the angiogenesis, forming the periosteal buds. It's going to carry our osteoprogenitors into the marrow cavity to make our ossification centers, and then also the hematopoietic cells that are going to exist within that marrow cavity and create your blood cells. So here's our situation now. We have a periosteum now. It's not a perichondrium anymore. The bone collar is continuing to grow all the way around, and we'll have our periosteal buds now, so just blood vessels growing in. First, they grow into, so let's put a 1 here, they grow into the diaphysis, so the shaft of the bone, and they form the primary ossification center there. That primary ossification center, full of those osteoprogenitors. They're going to make osteoclasts, which are going to make osteocytes. We're building bone, and it's going to be spreading out in all directions. Second, we have periosteal buds forming into the epiphyses, both the proximal epiphysis and the distal epiphysis. we create with that these secondary ossification centers, so clusters of osteoprogenitors in the epiphyses. They turn into osteoblasts, which start building bone, turn into osteocytes, and that spreads, oops, I had to go the wrong way, and that spreads out in all directions. And eventually, they're going to meet, but not yet, because there is another thing called the epiphyseal plate, or the growth plate. This is a piece of hyaline cartilage. And that allows you to grow longitudinally. Longitudinal growth. That just means allows you to grow longer, allows the bone to grow in a longitudinal direction, which would be, up and down. So how this works is, as you're a child, your growth plate, this piece of hyaline cartilage, is going to be growing. It's going to be growing out. And the bone, this primary ossification center, is sort of chasing it. It's going to sort of fill in part of it. But the rest of the plate is growing away from it. And they're going to be growing at the same pace. And that is because of pituitary growth hormone, which I'll just call growth hormone. And it causes both hyaline cartilage and bone to grow at the same pace. So this hyaline cartilage is growing away from the bone. The bone is chasing, trying to fill in that hyaline cartilage, but it can't quite catch up. Once puberty happens, sex hormones, so testosterone and estrogen, come into play, and they cause bone to grow faster than cartilage, so the bone's going to kind of fill in that cartilage faster than the cartilage can grow, and we just fill in that plate, and you cannot grow any further once that process is done, and that's why you stop growing. Okay, now also, while all of that is happening, so while these ossification centers are growing in every direction, the bone collar is forming the compact bone along the outside, we also have, of course, our osteoclasts. Remember, osteoclasts are responsible for breaking down bones. They're like the negative feedback for this whole process. They are breaking down some of this bone that's being built to create more of a spongy bone situation in here rather than a compact bone, because we really don't want compact bone in here. We want it to be all spongy bone. So we're going to be using that, or doing that in this area all throughout the marrow cavity. So that is ossification.